Hey class, I wanted to make a brief video for you all to help you get started on this first question on the workshop. So to get started, as the question actually asks you to do in part A, we need to begin by looking at a free body diagram. And I actually give you a hint here in part A that I want a free body diagram not only for the beam, but also for the pulley C as well. So if we start by looking at the beam's going to have two downward weight forces. The weight of the load on the hook, so I'll call this maybe W1, and then also the weight of the beam itself, which would act at its center of mass. So here I would call that WB, the weight of the beam. And we don't know where W1 is. It might be on the other side depending on how big X is, but I'll just draw it here for now. And then additionally, pulling up, we have two tension forces. We have the tension at A, and then we also have the tension at B. But before I label that TB, if you notice, right, the tension pulling up here at point B is the same rope as being pulled down by the pull force P. So really, that should imply to us that TB and P are just the same thing. So I'm actually just going to call this force P here. Now it doesn't hurt to label some of your distances on here as well, just to help stay organized when it comes to doing torques. So we know the distance between A and B is 0.9 meters. We know the distance to W1 is called X, and we don't have a value for that yet. And then we also know the distance to WB is going to be 0.45 meters since it's at the center of the beam. So that's that. Now looking at the pulley, if we think about this pulley here, it has that pull force P, also known as TB, right? Pulling down twice, once on each side, as is normal with a pulley. And then pulling up in the center is this other cable's tension here. But if we follow that over, that's the same tension acting up at A, right? So that would actually just be TA. So the hint that I tried to imply to you all by telling you to draw a free body diagram for block C is if you do some of the forces in the Y direction for pulley C, assume it's in equilibrium, as we're told here in parts B and C, then what that means is you'd have TA minus P equals 0, or TA equals 2 times P. So once you have that, you can then go back and look at the beam. And the interesting thing is, since TA is 2P, if we do some of the forces on the beam, check it out. Some of the forces on the beam in the vertical direction should also be equal to 0, which would be TA plus P minus W1 minus W of the beam equals 0. And TA is just 2P. So we have 2P plus P must be equal to the two weights added together, which are 6,000 and 1,000, so just 7,000 newtons in total. So right there, you can solve for P simply by doing some of the forces. You haven't even had to look at torque yet. So I'll let you solve for P there. Then you want to do some of the forces based on this picture here. And so when you go to do some of the torques based on that picture there. And so if you go to do some of the torques, looking at the beam once again, you're going to need to start by choosing an axis, right? So we're saying sum of the torque equals 0, and it's up to you to choose an axis point. You could choose a point like A, the middle of the rod, or over here at P, or B, excuse me, as well. I personally would probably go with A, so then TA becomes a force that generates 0 torque, and you just have the two negative torques from W1 and WB, and the positive torque from P pulling up on the opposite side of the beam. But I'm going to let you all practice that sum of the torques there on your own based on choosing A as your axis. All right? Okay, fine. I'll give you a few hints. So again, just to help out, it's the end of the term, right? So you have TA causing 0 torque, right? So you get rid of that. And then you're left with a positive torque due to counterclockwise rotation of the P force at point B. Sorry about my distraction. Gus is smelling my face very closely, and I can hardly see my iPad right now. Huh, but you're a good boy. I know. Okay, let's finish this here. So we have P at the distance of 0.9 meters and that's a positive torque. And then we have a negative torque from the weight of the beam at its distance, which would be 0.45 meters. And then we'd have minus weight 1, generating a negative torque again, because it would cause clockwise rotation at a distance of x, which we don't know. And all of those torques have to equal 0 for it to be in equilibrium. So now, since you know all the forces, you can solve for x. So I'll stop there now. Anyway, have a box-worthy night. I hope that helps.